Okay, ladies and gentlemen, welcome to my channel. Today we'll be discussing about how to calculate a short circuit calculations. Okay, so in my one of my videos, you have commented that you want to calculate how to perform a short circuit calculations. Okay, and I think one more guy has some commented that he wants to calculate a HV cable sizing calculation based on a 500 kVA transformer. Okay, so let's see this both the queries we will club into one and we will see together basically how to calculate short circuit calculations. Okay, so today in this video I will give you one thumb rule. Okay, so in a small simple formula you will be able to do a quick calculations. So if anybody is asking you, give me the short circuit calculations at the secondary side of a transformer or at the primary side of a transformer. So with some two values, you will be able to calculate the fault level. Now let's see. The formula that let's take an example of this transformer that is 110 by 13.8 kV. Okay, 63/80 MVA transformer. See, this is the same example which we have taken in my first video. Okay, so you can relate to that. And percentage impedance is 17%. So if you have to calculate the fault MVA at the secondary side, okay, so you have to consider this power MVA. This is the highest rating. 63/80 MVA is the highest MVA power rating of the transformer. So let's consider this 80 MVA divided by your percentage impedance, which is 17%. Okay, 17%. So we'll take this example here again. 80 divided by 17% is your 0.7. Okay, this is your FMVA or nothing but a fault MVA. Okay, so which will give around 80 divided by 0.417 will give around 470 MVA. Okay, so this is your fault MVA. So simple formula is once you got a fault MVA, we can calculate the short circuit current. That is fault current. So this fault current is equal to fault MVA divided by 1.732 into system voltage. Okay, because this fault MVA is root 3 into system voltage into fault current. So the fault current is fault MVA divided by root 3 into system voltage. So you know what is fault MVA, that is 470 divided by root 3. This is your 1.732 is nothing but the root 3 into system voltage. System voltage is, since you are finding the short circuit current or fault current at the secondary side, okay, you have to consider this system voltage. If you are finding the fault current at primary side, okay, at primary side, then you are taken system voltage as 110 kV, like primary side. Now it is secondary side, that's why we are considering secondary voltage, that is 13.8 kV. So this will give you around, if you calculate, this is root 3 is nothing but 1.732. This will give around something 19.6 K, which is equivalent to 20 K. Okay, so this is your fault current. This is your 20 K fault current at the secondary side. Okay, now based on this fault current, you will be able to calculate what is the minimum cross sectional area required for HV cable. So with this simple formula, with these two values, that is your 80 MVA, that is power MVA, and percentage impedance, we will be getting fault MVA, and then from fault MVA divided by root 3 into system voltage, that is secondary side voltage. Why? Because we are considering fault MVA at the secondary side. We have taken it 13.8 kV, so 470 divided by root 3 into 13.8 kV gives you 20 kV. So you got the fault current. So this is what just a simple way of doing calculations for to find a fault level at the transformer secondary side. Okay. Now let's see one more query, that is how to calculate HV cable size, minimum cross sectional area for HV cable, that is A is equal to, formula is short circuit current into root T divided by constant K. This is a minimum cross sectional area required for HV cable. Okay. Okay, let's take one example of 11 by 0.415 kV 500 kV transformer. Okay, so we'll see here. So we will be calculating the fault KVA at the primary side of the transformer. So let's take we have two values, that is 500 kVA this, and a percentage impedance 6% we have considered. So 500 kVA divided by 0.06 will give you 8333 kVA. Okay. Now once we divide this fault kVA divided by root 3 into system voltage, that is 11 kV, since we are calculating the fault kVA at the HV side. Okay, at the HV side. So you will get some approximate values 0.5 kVA. Okay. Now this is your fault current. So now if you consider this fault current into this formula, it's 0.5 into root T. Root T is your time of clearing the fault, which is equivalent to 1 seconds. T is your 1 seconds. Okay, so 0.5 K into root T divided by 143. Now this constant is based on your type of cable you have used. Like for example, if you are using copper, the value is 143, and if you are using aluminium, the value is around 91. Okay, so depending on the type of the cable material, we take these values. So approximately you will get value that is 2.439 mm square. That means the minimum cross sectional area of the cable which we are going to use at the HV side should be about this size. So which is very low. This 2.4, I mean, you can, in fact, you can take any size. So minimum size for HV side you will get like single core 630 square mm you will get. So I have just considered this example because someone has asked me to calculate the HV cable at the primary side. Normally the transformer rating is not that so low, but this is maybe you may be using this at a distribution end. That's why the rating normally at the distribution end is just 500, or sometimes it is 630 kV also. Okay, so you can take minimum cross sectional area like any standard value of HV cable. Normally HV cable starts from 300 also, so you can go for 300 square mm cable. Okay, that is a single run or a 3 core 300, you can take it. So that's it for the video. So if you have any doubts, please keep commenting, and you can ask me doubts to the comments, so that based on your doubts I can make more and more videos. Okay, so keep watching, and I will keep clearing your doubts. That's it. And anything, if you want to take some courses on related to this electrical design, if you are really interested, then you can call me on my number, which is be displaying on the thumbnail. So please call and keep commenting and keep watching. That's it. Thank you for the video.